Hello there, and welcome to the Sleepy Science Channel. Tonight, we'll be exploring one of the most extraordinary natural features on Earth, the Grand Canyon. It is a landscape that reveals the incredible power of natural forces and the amazing impact they can have over immense periods of time. To look across it is to see the scale of the planet made visible, a reminder that Earth is always shaping and reshaping itself. But our journey will not stop here. We'll move beyond Arizona to explore other great canyons across the world, from deserts to rainforests, from the high peaks of the Himalayas to the depths of the oceans. And further still, we'll visit the colossal canyons of other worlds, where planetary forces carve landscapes as dramatic as any on Earth. If you enjoy these calm explorations, I invite you to like and subscribe, or share a thought in the comments below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax. Allow your mind to soften and your breathing to slow as we dive into this epic journey through the Earth. Let's begin. The Grand Canyon reveals nearly 2 billion years of Earth's history. It is often described as a natural time machine. Within its walls, we can see a cross-section of Earth's past, reaching back almost 2 billion years. Unlike most landscapes that hide their history under soil or vegetation, the canyon lays it bare in colored bands of stone. The upper layers capture hundreds of millions of years of shifting environments, while the deepest exposed rock descends into some of the oldest chapters of Earth's story. To stand at the rim is to see not just distance, but time stacked before your eyes. Oceans that once spread across the land, deserts that turned to stone, and rivers that ran long before humans ever appeared. Scientists study these layers like the pages of an open book, each one preserving evidence of climates, ecosystems, and events that shaped the planet long before the modern world existed. Some rocks at the canyon's base are among the oldest on the planet. At the very bottom of the Grand Canyon lies a formation known as the Vishnu Basement Rocks, where metamorphic stones called schists and ancient intrusions of granite record Earth's early history. These rocks are not just old, they are astonishingly old, dating back close to 2 billion years. That makes them nearly half the age of our entire planet. In these layers, scientists see the remnants of mountain ranges that have long since vanished, the compressed remains of ocean crust, and the deep scars of tectonic collisions that assembled the continents. To touch them is to make contact with matter that has survived countless transformations, heated, crushed, folded, and uplifted, yet still present today. Few places on Earth expose such ancient rocks at the surface, and the Grand Canyon offers one of the clearest, most dramatic windows into the raw beginnings of the continents we now walk upon. The Colorado River began carving the canyon millions of years ago. The Colorado River, winding through the canyon's depths today, has been at work for millions of years. While the exact timeline remains debated, most scientists agree the river began cutting into the Colorado Plateau at least 5 to 6 million years ago, and possibly earlier. Once water found a pathway through uplifted stone, gravity and flow did the rest, relentlessly eroding softer layers and widening fractures in harder rock. Over time, tributaries joined the main river, deepening and expanding the chasm into the vast canyon we now know. What makes this story extraordinary is the slow, persistent scale of the work. Every bend, rapid, and cliff is a reminder of water's quiet but unstoppable power. In the modern river's course, scientists see echoes of a far older landscape, one reshaped again and again, proving that even the hardest stone yields when water and time work together without end. The canyon itself is much younger than its ancient rocks. One of the most surprising truths about the Grand Canyon is that, While its rocks are unimaginably old, the canyon itself is geologically young. The oldest exposed formations date back nearly 2 billion years, yet the chasm carved through them may only be a few million years old. This means the canyon is not a relic frozen in the past, but an ongoing, living feature of Earth's surface. Tectonic uplift raised the Colorado Plateau, giving the river the steep gradient it needed to slice downward through layers of stone. In this way, the canyon is more like an open wound in the Earth's crust, fresh when compared to the age of the rocks it reveals. For scientists, this creates an intriguing paradox. Ancient stone telling stories of vanished worlds, cut open by processes still unfolding. The canyon is both a window into the past and a reminder of Earth's restless present. The Grand Canyon was deepened by powerful erosion over time. Erosion is the sculptor that gave the Grand Canyon its depth and grandeur. While the Colorado River was the primary tool, the full process involved many agents working together: water, wind, ice, and gravity. Rain and snowmelt trickled into cracks, slowly prying rocks apart through freezing and thawing. Tributary streams widened the chasm, carving side canyons that stretch like veins into the plateau. Rockfalls thundered down from the walls, carrying boulders into the depths, where the river ground them into sand and gravel. Even wind, carrying fine dust, helped wear down surfaces over time. Over millions of years, these forces deepened the canyon mile by mile, creating a labyrinth of ridges, cliffs, and valleys. What makes the Grand Canyon extraordinary is the scale of these combined processes, a natural experiment in erosion that continues today, shaping a landscape both breathtaking and scientifically invaluable. The Vishnu schist at the bottom shimmers with ancient minerals. Deep within the Grand Canyon lies the Vishnu schist, a dark, crystalline rock that gleams with minerals like mica and garnet. These rocks were formed under immense heat and pressure nearly 2 billion years ago, when tectonic forces transformed existing stone into something new. As light strikes the schist, the minerals catch and glimmer, revealing tiny crystals forged in Earth's ancient interior. Geologists prize these rocks because they record events from the Archean and Proterozoic eons, a time when life on Earth was still microscopic and the continents were assembling into new forms. To encounter the Vishnu schist is to stand before some of the most durable witnesses of planetary history. These rocks are not only scientifically important, but also visually striking, their dark sheen contrasting with the lighter layers above. In their shimmer lies the story of Earth's deep interior, preserved and revealed at the canyon's very base. Fossils in the canyon tell stories of seas, deserts, and rivers long gone. The Grand Canyon is not just a monument of stone, it is also a record of ancient life. Fossils found in its walls reveal environments that shifted dramatically over hundreds of millions of years. In some layers, marine fossils show that the region was once covered by shallow seas filled with brachiopods, corals, and trilobites. In others, footprints and plant impressions mark ancient riverbanks and floodplains. There are even desert sandstones preserving the ripples of long-vanished dunes. Each fossil offers a clue to the environments that came before: oceans rising and falling, rivers changing course, deserts sweeping in, and forests taking root. Together, they form a timeline of Earth's changing surface, showing how ecosystems appear, evolve, and vanish. For paleontologists, the Grand Canyon is a living archive, not only of rock and water, but of the creatures and landscapes that once thrived where cliffs and valleys now stand. Volcanic lava once poured across parts of the canyon. Although the Grand Canyon is most famous for its sedimentary layers, it also bears the marks of fire. In its western reaches, fields of hardened basalt reveal where volcanic eruptions once spilled molten rock across the landscape. These flows, occurring as recently as a few 100,000 years ago, cascaded into the canyon itself, temporarily damming the Colorado River. Behind these natural dams, vast lakes formed, only to be breached later when the river forced its way through. The evidence of these events can still be traced in basalt cliffs and scattered volcanic cones that rise above the canyon rim. For geologists, these lava flows show how the canyon is not simply a story of water and stone, but also of Earth's fiery interior shaping the surface. They remind us that the Grand Canyon is not static, but a dynamic landscape influenced by multiple powerful forces. The canyon walls display a rainbow of colors at sunrise and sunset. One of the most striking features of the Grand Canyon is the play of color across its walls. At sunrise and sunset, when light strikes at a low angle, the layers ignite in vivid shades of red, orange, gold, and violet. These colors come from the mineral content of the rocks, iron oxides producing reds and yellows, limestone reflecting softer creams, and darker layers absorbing shadows that deepen the contrasts. The canyon's vast size amplifies this effect, as ridges and cliffs catch light differently, creating a shifting mosaic that changes by the minute. Scientists note that atmospheric conditions, humidity, dust, even wildfire smoke can alter the palette, sometimes giving the canyon surreal hues. For visitors, the effect is nothing short of breathtaking, a reminder that geology is not just ancient and static, but alive with color, shape, and the changing light of every day. The rock layers preserve clues about changing ancient climates. The Grand Canyon's stone walls are not just layers of rock, they are evidence of climates that shifted across vast stretches of time. Sandstones preserve the marks of ancient deserts where winds piled dunes high. Limestones record periods when shallow seas covered the region, leaving behind shells and corals. Shales reveal muddy floodplains and slow-moving rivers. By studying these rocks, scientists reconstruct past climates, from tropical coastlines to arid interiors. These shifts show how Earth has always been dynamic, with continents drifting, sea levels rising and falling, and climates transforming ecosystems again and again. The canyon is therefore more than a dramatic landscape. It is an environmental archive, demonstrating that change is constant and often dramatic. For researchers, it provides essential lessons about how climates evolve, offering a deep-time perspective on the patterns shaping the world we live in today. The Grand Canyon stretches for hundreds of miles across Arizona. The Grand Canyon is not just a deep valley, but an immense stretch of landscape that extends for roughly 277 miles across northern Arizona. This makes it one of the largest continuous geological features on Earth, cutting across the Colorado Plateau like a scar carved by time. What makes this distance remarkable is that along its course, the canyon is not uniform. Its width, depth, and even the character of the rock layers change, creating a shifting panorama of cliffs, buttes, mesas, and side canyons. From the eastern desert view to the remote western reaches near Lake Mead, the canyon displays new variations at every turn. This enormous length also means that the climate and ecosystems shift significantly from one end to the other, with some regions experiencing desert conditions while others host forests. To explore the canyon's full reach is to journey across a cross-section of the American Southwest itself. At its widest, the canyon spans more than 10 miles. While the Grand Canyon is already known for its depth, its width is equally staggering. In some sections, the distance from one rim to the other exceeds 10 miles, creating a gulf so vast that details on the opposite side can blur into the horizon. This width is not consistent. In some places, the canyon narrows dramatically, while in others, tributary valleys and eroded cliffs widen the gap to an immense expanse. Scientists attribute this variation to differences in rock type and erosion, where softer layers give way more easily, allowing the canyon to spread outward. For those who stand at one rim and look across, the sheer breadth emphasizes the scale of the forces involved in carving it. It is not simply a river valley, but a colossal landscape opened wide by the work of water, gravity, and time. In places, the canyon plunges more than a mile deep. Depth is what makes the Grand Canyon so unforgettable. At its deepest points, the canyon floor lies more than a vertical mile below the rim, creating a descent steeper than almost anywhere else on Earth. The sheer drop is not uniform, but shaped by countless cliffs, terraces, and slopes that step downward through layers of rock. For hikers, this depth translates into dramatic changes in environment, temperature, and air density as they descend. Scientists study the canyon's depth as a record of erosion, noting that the Colorado River carved downward, while uplift of the Colorado Plateau simultaneously raised the surrounding land higher. The result is a dramatic chasm, whose scale challenges human perception. Looking down from the rim, the river can appear impossibly small, yet it has been the engine driving this immense excavation over millions of years. Standing on the rim, you can see more than 90 miles on a clear day. From the canyon's rims, the view stretches astonishingly far. On days when the air is clear and free of dust or haze, visitors can see more than 90 miles into the distance. This is possible because the Colorado Plateau sits at a high elevation, giving observers a vantage point across a broad horizon. The clarity of the air in this region, particularly in cooler months, allows sunlight to reveal ridges, cliffs, and mesas that seem to stack endlessly into the distance. Scientists note that the dry desert climate helps preserve visibility, though wildfires, pollution, and seasonal storms can sometimes obscure it. For those who experience these long views, the sensation is almost otherworldly, a panorama so vast it exceeds the limits of normal depth perception. This ability to see across such great distances is part of what makes the Grand Canyon one of the most spectacular viewpoints on the planet. The canyon creates its own weather patterns. The Grand Canyon is so large that it generates localized weather systems. The steep walls and deep chasm create temperature gradients that drive unique patterns of wind, cloud formation, and precipitation. During summer, heat trapped in the canyon can cause rising air currents, leading to sudden thunderstorms that form directly above the cliffs and valleys. In winter, cold air often pools along the river, creating inversions where the rim basks in sunlight, while the depths remain shrouded in fog. These microclimates are not just curiosities, they shape ecosystems, determining where plants grow, where animals migrate, and how water flows. Scientists study these weather effects as examples of how topography influences climate on a local scale. For visitors, it means conditions at the rim and the river can feel like entirely different worlds, with sudden shifts in wind, cloud, or light happening right before their eyes. The temperature can differ by dozens of degrees between rim and river. One of the most striking experiences of the Grand Canyon is the extreme difference in temperature between the rim and the river. On summer days, the canyon rim may be comfortably warm, while the inner gorge along the Colorado River can reach scorching conditions, often more than 30 degrees hotter. This difference is caused by the elevation drop of more than a mile, which affects air density and heat retention. Cooler air lingers on the rim, while the deeper sections trap heat like an oven, especially when sunlight reflects off dark rock surfaces. For hikers, this can create dangerous conditions, as a descent begun in mild weather can quickly turn into a battle against extreme heat. The temperature gradient also supports diverse ecosystems, with alpine forests at higher elevations giving way to desert plants near the river. This contrast makes the Grand Canyon a natural laboratory for studying microclimates in action. Shadows from the rim can take hours to reach the canyon floor. The scale of the Grand Canyon creates unusual relationships with light. In the morning, when the sun rises above the rim, shadows cast by cliffs can stretch for miles across the chasm. In some places, these shadows take hours to recede, leaving parts of the canyon floor in darkness long after sunrise. The same is true in the evening, when the rim's towering walls cast enormous shadows that descend slowly into the depths. Scientists note that this prolonged shading affects temperatures, evaporation rates, and even plant growth in certain areas. It also contributes to the canyon's dramatic appearance, as layers of light and shadow reveal details in constantly shifting ways. For those who watch carefully, the slow crawl of shadow down the walls is a reminder of the canyon's immense vertical scale, measured not only in stone, but in the passage of light across its depths. Sound echoes travel strangely across the vast spaces. Sound behaves in unexpected ways within the Grand Canyon. Shouts, claps, or echoes of footsteps can travel long distances, bouncing off cliffs and returning in strange patterns. In some spots, echoes repeat multiple times, as if the canyon is answering back. In others, sound is swallowed into silence, absorbed by uneven surfaces and lost in the vast space. Scientists studying acoustics note that the canyon's size and irregular geometry create unusual effects, making it a natural laboratory for the physics of sound. For wildlife, these properties can aid or challenge survival, as predators and prey alike rely on sound for communication. Visitors often describe the experience as eerie, because the canyon does not respond like ordinary landscapes. Its acoustics make even the smallest noise feel amplified, while the largest noises can vanish unexpectedly into the vastness of stone and air. Some points on the rim feel like gazing across another world. The Grand Canyon has often been compared to alien landscapes because of its scale, color, and depth. From certain points on the rim, the view is so immense that it overwhelms normal perception, making it feel like gazing across the surface of another planet. The desert palette of red cliffs, pale stone, and violet shadows mirrors images captured by spacecraft on Mars. Scientists studying the canyon have even drawn parallels between its erosional features and those observed on Martian valleys and chasms. For visitors, the effect is equally striking on an emotional level. The sheer scale dwarfs the human mind's ability to measure it intuitively, creating a sense of disorientation mixed with awe. In this way, the Grand Canyon does not just teach us about Earth's history, it challenges our sense of place, reminding us that landscapes can feel alien even when they are found here at home. Flying over the canyon reveals patterns hidden from the ground. From the rim, the Grand Canyon already appears immense, but from the air, an entirely different perspective emerges. Looking down from a plane or helicopter, the canyon resembles an intricate network of veins branching out from the Colorado River, with side canyons and tributaries spreading across the plateau like the branches of a palm tree. These patterns are nearly impossible to grasp from ground level, where cliffs block the view of adjacent valleys. Scientists use aerial surveys and satellite imagery to map these systems, revealing erosion patterns, hidden caves, and ancient landslides. For researchers, this bird's-eye perspective provides crucial data on how the canyon evolved and continues to change. For those fortunate enough to fly over it, the effect is breathtaking. The immensity of the canyon laid bare, its scale transformed from overwhelming to comprehensible, like seeing the blueprint of nature's work drawn across the land. Indigenous peoples have lived at the Grand Canyon for thousands of years. Long before it became a national park or a symbol of natural wonder, the Grand Canyon was home to indigenous peoples who lived, hunted, farmed, and thrived along its cliffs and river valleys. Archaeological evidence shows human presence in the region for more than 12,000 years. These early inhabitants adapted to the canyon's diverse environments, moving with the seasons and making use of its natural resources. Ancient tools, dwellings, and food remains reveal a long history of survival and innovation in a place of great challenge and great opportunity. The canyon provided shelter, fertile patches of land, and spiritual meaning that remains deeply significant to many native nations today. To understand the Grand Canyon is not only to see its geological story, but also to recognize its human story, one that stretches back millennia, connecting past and present in ways that endure across time. The Hopi consider the canyon a sacred place of origins. For the Hopi people, the Grand Canyon is not merely a landscape, but a place of profound spiritual importance. According to Hopi tradition, it is connected to their emergence into this world, a sacred space tied to the origins of their people and their ongoing relationship with the earth. Certain sites within the canyon are regarded as deeply significant, and ceremonies and stories continue to honor these connections. This perspective illustrates that the canyon is more than geological wonder. It is a cultural landmark, woven into the identity and heritage of those who have lived alongside it for countless generations. For scientists, the canyon is a place to study rock and time. For the Hopi, it is a living story, a reminder that landscapes hold meaning beyond their physical form. These overlapping perspectives deepen our understanding of why the canyon matters to humanity as a whole. The Havasupai people still live deep within the canyon. Among the most remarkable stories of human presence in the Grand Canyon is that of the Havasupai people. Unlike most groups who live on the rim or nearby plateaus, the Havasupai continue to inhabit villages deep within the canyon itself. Their home lies near hidden waterfalls and fertile lands nourished by clear streams that descend into the Colorado River. The name Havasupai means people of the blue-green waters, reflecting their deep connection to these striking turquoise flows. For centuries, the Havasupai have cultivated crops, built homes, and maintained a lifestyle uniquely adapted to canyon life. Today, they continue to live there, preserving their traditions while welcoming visitors who hike or ride into their valley. Their enduring presence demonstrates not only human resilience, but also the intimate relationship between people and the landscapes they inhabit. The Havasupai are a living link between the canyon's ancient past and its living present. Ancient Puebloan dwellings can still be found in cliff walls. Scattered throughout the Grand Canyon are traces of the ancient Puebloan people, also known as the ancestral Puebloans. They built dwellings high within the cliffs, where stone and mud structures still cling to alcoves sheltered from wind and rain. These homes, some dating back nearly 1,000 years, reveal a sophisticated adaptation to the canyon environment. The locations offered safety from flooding and invaders, while still allowing access to farming areas and water sources. Pottery shards, tools, and food remains found in these sites tell of a culture deeply attuned to its surroundings. Many of these dwellings remain remarkably well preserved due to the dry climate, serving as archaeological windows into daily life centuries ago. For modern observers, these cliff dwellings stand as silent reminders that the canyon has always been more than empty space. It has been a lived-in, human landscape for countless generations. Petroglyphs etched into stone share stories of long ago. The walls of the Grand Canyon bear not only natural marks, but also the deliberate carvings of ancient peoples. Petroglyphs, images etched into stone surfaces, can be found throughout the canyon and its tributaries. These designs, some thousands of years old, depict animals, human figures, hunting scenes, and symbolic patterns whose meanings still resonate. Archaeologists interpret them as records of life, ritual, and communication, though many details remain mysteries. For indigenous peoples, these petroglyphs often carry spiritual or cultural significance, connecting modern communities to their ancestors. Unlike paintings, which can fade, petroglyphs endure in stone, making them some of the most enduring human marks on the landscape. Their presence reminds us that the Grand Canyon is not only a geological wonder, but also a cultural archive, where human stories are literally carved into the walls alongside the natural record of time. Spanish explorers first recorded the canyon centuries ago. The first Europeans to encounter the Grand Canyon were members of a Spanish expedition in the 16th century, led by Garcia López de Cárdenas. Searching for the fabled 7 cities of gold, the explorers instead stumbled upon the immense chasm of the canyon. Overwhelmed by its scale, they attempted to climb down, only to discover the descent was far greater than they expected. Their written accounts describe the canyon's vastness, but also their inability to fully grasp or navigate it. This encounter marked the beginning of the canyon's place in recorded history, though for thousands of years it had already been home to indigenous peoples. For historians, the story illustrates how even seasoned explorers could be humbled by landscapes that defied their expectations. The Spanish left with awe but little success in crossing it, highlighting how formidable the Grand Canyon appeared to those seeing it for the first time. Early American explorers struggled to cross its sheer cliffs. In the 19th century, American explorers moving westward came upon the Grand Canyon and were immediately challenged by its scale. Attempts to descend or cross the canyon often ended in failure, as sheer cliffs and treacherous terrain blocked their paths. Accounts from this time describe long detours to find crossing points, with some expeditions nearly perishing in the attempt. The canyon was not simply an obstacle on a map. It was an immense barrier that resisted human passage. For early settlers and explorers, the canyon highlighted the raw and untamed character of the American West. Only later, with improved surveying, trails, and equipment, did it become more navigable. These struggles emphasize that the Grand Canyon, now associated with tourism and recreation, was once viewed primarily as a formidable wilderness, demanding respect and caution from anyone who dared approach its depths. John Wesley Powell led a famous river expedition in the 19th century. One of the most legendary chapters in Grand Canyon history belongs to John Wesley Powell, a one-armed Civil War veteran turned geologist and explorer. In 1869, Powell led an expedition down the Colorado River, through the uncharted canyon, using wooden boats to brave rapids no outsider had attempted before. The journey was perilous. Boats were lost, supplies dwindled, and some men abandoned the effort. Yet Powell pressed on, documenting the geology, geography, and challenges of the river. His expedition produced some of the earliest detailed accounts of the Grand Canyon, transforming it from an unknown obstacle into a subject of scientific and public fascination. Powell's courage and determination became legendary, and his reports helped establish the canyon as a site of immense geological importance. Today, his name is inseparable from the story of the canyon's exploration, symbolizing both risk and discovery. Railroads helped bring the canyon to the wider world. In the late 19th and early 20th centuries, railroads opened access to the Grand Canyon for the first time. Before this, the journey to the rim was long and arduous, undertaken only by explorers, local inhabitants, or the most determined travelers. With the arrival of rail lines, particularly the Santa Fe Railway, visitors could reach the South Rim with relative ease. This development transformed the canyon into a national attraction, bringing tourists, scientists, and artists to witness its grandeur. Hotels and viewing platforms soon followed, creating the foundation of modern tourism in the region. The railroad not only changed how people reached the canyon, but also how they perceived it, shifting from a remote wilderness to a celebrated natural wonder accessible to the wider public. This moment marked the beginning of the canyon's role as both a scientific landmark and a cultural icon. The canyon was declared a national park in the early 20th century. In 1919, the Grand Canyon was officially designated as a United States national park, solidifying its place as one of the most protected and celebrated landscapes in the world. The designation followed years of advocacy, including efforts by President Theodore Roosevelt, who called the canyon a wonder that should remain untouched for future generations. As a national park, the Grand Canyon became both a preserved wilderness and a symbol of natural heritage. Protection ensured that its geological features, ecosystems, and cultural sites would remain safeguarded against exploitation or unchecked development. Since then, the park has welcomed millions of visitors from across the globe, becoming one of the most visited natural sites on Earth. Its status as a national park reflects a recognition not only of its scientific value, but also of its role as a shared treasure, inspiring awe and curiosity for generations to come. California condors soar over the Grand Canyon's cliffs. The Grand Canyon is one of the last great refuges for the California condor, the largest flying bird in North America. With wings stretching nearly 10 feet across, these remarkable birds glide effortlessly along the canyon's cliffs, using rising columns of warm air to stay aloft for hours with barely a wind beat. Once on the brink of extinction, the condor population dwindled to fewer than 30 individuals by the late 20th century. Through an ambitious conservation program involving captive breeding and release, their numbers have slowly risen. Today, the Grand Canyon is one of the few places where visitors may look up to see this ancient species, a bird whose lineage stretches back millions of years. The sight of a condor circling above the canyon walls is a reminder of resilience, not just of landscapes, but of the creatures that depend on them and the efforts of humans to bring them back from the edge. Desert bighorn sheep skillfully navigate the steep terrain. Few animals demonstrate adaptation to the Grand Canyon's vertical world as impressively as the desert bighorn sheep. These sure-footed mammals roam the canyon's cliffs and ledges, balancing with astonishing agility where a single misstep would mean disaster. Their hooves are uniquely suited for this life, with rough bottoms that grip rocky surfaces like natural climbing shoes. The sheep use the steep terrain as protection from predators, retreating to heights where few can follow. For centuries, indigenous peoples admired and hunted these animals, whose presence continues to define the canyon's ecosystem today. Bighorn sheep are also an indicator species. Their survival reflects the health of the canyon's water sources and vegetation. Observing them gracefully climbing near vertical slopes offers a living demonstration of evolution in action, a reminder that even the most extreme environments provide niches where life not only survives, but thrives with remarkable elegance. Ringtail cats roam the canyon at night. The ringtail cat, despite its name, is not a cat at all, but a small nocturnal relative of the raccoon. These elusive creatures prowl the Grand Canyon under cover of darkness, rarely seen by visitors but leaving traces of their presence in tracks and calls. With large, luminous eyes and long striped tails, ringtails are adapted perfectly for night hunting. They scale canyon walls and navigate ledges in search of insects, rodents, and fruit. Indigenous peoples once tamed ringtails as companions to keep food stores free of pests, giving them a long-standing relationship with humans. Today, they remain secretive residents of the canyon's ecosystems, helping to balance populations of smaller animals and insects. To glimpse one darting along the rocks under starlight is a rare privilege. Though overshadowed by more iconic species, the ringtail is a vital part of the canyon's nocturnal life, reminding us of the hidden creatures that thrive while we sleep. Rare endangered snails live in hidden springs. Among the most surprising inhabitants of the Grand Canyon are tiny freshwater snails, many of them found nowhere else on Earth. These delicate creatures live in isolated springs and seeps that dot the canyon walls, clinging to aquatic plants or the undersides of stones. Because each spring is its own miniature habitat, species have evolved in isolation, resulting in unique lineages with extremely limited ranges. Their survival depends entirely on the persistence of these hidden water sources, making them vulnerable to climate change, groundwater use, and habitat disturbance. Scientists study these snails as indicators of ecological health, because their fragility reflects the stability of their environment. Though they may be small and easily overlooked, they are as much a part of the canyon's story as condors or bighorn sheep. In their tiny shells lies a record of survival against the odds, carried out in the quietest corners of the canyon. The canyon's ecosystems range from desert cactus to pine forest. The Grand Canyon is often imagined as a single desert landscape, but in reality, it spans multiple ecosystems. Along the rim, cool conditions support forests of ponderosa pine, aspen, and spruce, while only a mile below, the scorching inner canyon hosts cacti, creosote bushes, and desert shrubs. The elevation changes within the canyon mimic the same climatic variation you'd encounter driving from Canada to Mexico. This vertical diversity allows an incredible range of plants and animals to coexist within a relatively compact area. For scientists, the Grand Canyon is a natural laboratory, showing how altitude and microclimate shape life. For visitors, it means hiking from rim to river feels like traveling through entirely different worlds. Each zone carries its own rhythms and communities, illustrating how ecosystems are layered vertically, just as the canyon's rocks are layered through time. Plants on the rim differ vastly from those on the riverbanks. The Grand Canyon's steep elevation drop creates dramatic contrasts in plant life. At the rim, cooler temperatures and higher rainfall allow forests of pine, juniper, and oak to dominate, resembling woodlands found far to the north. Descend toward the river, however, and the scene shifts to desert vegetation. Spiny cacti, hardy mesquite, and willows hugging the water's edge. In between are transitional zones with their own plant communities, from shrubs and grasses to wildflowers that burst into bloom after seasonal rains. These sharp differences occur because every 1,000 feet of elevation represents a significant change in climate. The result is a stacked sequence of habitats, each distinct yet connected, forming one of the richest botanical mosaics in North America. Scientists use the canyon to study how plants adapt to varying conditions in close proximity, while hikers experience the journey as a living demonstration of ecological diversity compressed into a single landscape. Unique species thrive in isolated side canyons. Beyond the main chasm of the Grand Canyon lie hundreds of smaller tributaries and side canyons, each forming a world of its own. Many of these places contain springs, shaded alcoves, and unique microclimates where plants and animals survive that are rare or absent elsewhere. Isolation allows species to evolve and persist in small, specialized populations, making side canyons hotspots of biodiversity. Some harbor relict species, plants that were once widespread but now survive only in sheltered niches. Others support amphibians, insects, or fish, whose entire populations are confined to a single canyon branch. For scientists, these side canyons are critical for understanding how isolation shapes evolution and survival. For explorers, they are places of mystery, hidden away from the main trails. To step into one is to enter a miniature ecosystem, where life clings to the narrow margins of water and shade within the vast desert landscape. Elk and mule deer wander the forested rims. Although the depths of the Grand Canyon are hot and dry, the higher elevations along the rims support expansive forests, and with them, large mammals like elk and mule deer. These animals graze on grasses, shrubs, and tree shoots, often appearing at dawn or dusk to feed in meadows or near water sources. Mule deer, easily recognized by their large ears, are particularly common along the South Rim. Elk, larger and more imposing, thrive in the cooler northern forests. Both species play important ecological roles, shaping plant communities and serving as prey for predators such as mountain lions. Their presence also links the canyon to broader ecosystems across the Colorado Plateau. For visitors, seeing an elk step out of the trees or a mule deer pause at the rim connects the canyon's wild landscape to the living rhythms of animals that have roamed these highlands for countless generations. Brightly colored lizards bask on sun-warmed rocks. Scattered throughout the Grand Canyon, lizards dart across rocks and trails, their quick movements and vivid colors making them a familiar sight. Species like the collared lizard display striking patterns of turquoise, green, and yellow, especially visible when males defend their territories. Others, such as whiptills and side-blotched lizards, use speed and camouflage to evade predators. These reptiles are perfectly suited to the canyon's harsh conditions. Their cold-blooded physiology allows them to thrive on heat absorbed from sun-baked stones, while their small size and agility let them slip into crevices to escape danger or regulate temperature. Lizards are key players in the canyon's food web, feeding on insects and, in turn, becoming prey for birds, snakes, and mammals. Their abundance and variety highlight how even small creatures adapt brilliantly to extremes. Watching one bask motionless on a glowing red rock captures the canyon's blend of resilience and beauty in miniature. Tiny frogs call from pools in shady grottos. Hidden within the Grand Canyon's maze of cliffs and side canyons are shady grottos and springs where small frogs make their homes. Unlike the arid cliffs above, these microhabitats remain moist year-round, creating oases where amphibians can survive. One notable species is the canyon tree frog, which clings to rocks near waterfalls and streams. During summer nights, their loud staccato calls echo against the stone, an unexpected sound in such a dry environment. These frogs are more than curiosities. They are ecological indicators. Because amphibians are highly sensitive to water quality and temperature, their presence signals the health of fragile aquatic habitats. For hikers stumbling upon them, the discovery can feel magical. A sudden burst of life in an otherwise parched landscape. These frogs remind us that the canyon is not only stone and silence, but also a sanctuary for delicate forms of life that persist against all odds. The Colorado River powers through the canyon's heart. At the center of the Grand Canyon lies the Colorado River, the restless force that carved much of the chasm we see today. Flowing for more than 1,000 miles from the Rocky Mountains to the Gulf of California, the river's course through the canyon stretches for nearly 300 miles. Along this route, it winds past sheer cliffs, cuts through ancient stone, and continues to deepen and shape the gorge. The river's power comes not just from its water, but from the sediment it carries. Sand, gravel, and boulders that grind the canyon deeper with every flood and surge. For indigenous peoples, the river has always been a source of sustenance and spiritual meaning. For scientists, it remains a case study in the slow but unstoppable force of erosion. To stand beside it is to witness the living heart of the canyon, endlessly sculpting the landscape. River rapids are ranked among the fiercest in North America. The Colorado River is renowned for its whitewater rapids, and those within the Grand Canyon are among the most challenging in the world. Rapids such as Lava Falls, Crystal, and Horn Creek are legendary among rafters, with waves and drops powerful enough to test even the most experienced adventurers. Rapids form where boulders, landslides, or resistant rock layers constrict the river, forcing water into turbulence and creating standing waves that can tower higher than a person. The Grand Canyon's rapids are ranked on a unique scale from 1 to 10, with the fiercest earning the highest numbers. For scientists, rapids demonstrate how rivers interact with geology in real time, reshaping themselves after floods and rockfalls. For those who dare to navigate them, the experience is unforgettable, a direct encounter with raw natural power, set against the backdrop of one of Earth's most spectacular landscapes. Rafting expeditions can take weeks to complete. Rafting through the Grand Canyon is not a short adventure. Full expeditions covering the entire length of the river through the canyon can last more than 2 weeks. Along the way, rafters navigate dozens of rapids, camp on shifting sandbars, and explore side canyons, accessible only from the water. The journey is both physically demanding and profoundly immersive. Without roads or easy exits, the river becomes a world unto itself, cut off from modern noise and distractions. Scientists, too, undertake long river trips to study geology, hydrology, and ecosystems firsthand. These expeditions offer insights that cannot be gained from the rim or short visits. For many, the length of the journey is what makes it transformative, requiring adaptation to the rhythms of the river and the canyon. It is a reminder that some landscapes can only be understood through time, patience, and sustained presence. The river has changed course many times through history. The Colorado River we see today is only the latest chapter in a long story of shifting pathways. Over millions of years, the river has changed course repeatedly, diverted by tectonic uplift, landslides, and volcanic activity. Evidence of abandoned channels, filled with sediments and fossils, can be found throughout the canyon and surrounding plateau. These shifts reveal how dynamic the landscape is, with water constantly seeking new routes through rock. In some cases, the river was temporarily dammed by lava flows or landslides, creating vast lakes that eventually drained. In others, uplift forced the river to cut deeper, abandoning older valleys. For scientists, studying these paleochannels is essential for reconstructing the canyon's geologic history. For visitors, it is a humbling reminder that the canyon we admire today is not permanent. The river continues to evolve, and its course in the distant future may look very different from what we know now. Dams upstream have altered sediment flow and river ecology. Modern engineering has reshaped the Colorado River, particularly with the construction of Glen Canyon Dam upstream of the Grand Canyon. Completed in the 1960s, the dam traps vast amounts of sediment that would naturally replenish sandbars and beaches downstream. As a result, the river through the canyon has become clearer but also less dynamic, altering habitats for fish, plants, and animals. Scientists have observed declines in native species that depended on seasonal floods and shifting sediment. In response, controlled floods have occasionally been released from the dam to mimic natural conditions, redistributing sand and rebuilding riverbanks. These experiments highlight the complex relationship between human infrastructure and natural landscapes. The dam demonstrates both the ingenuity and the consequences of altering major rivers. Within the canyon, its impact is a living example of how modern choices continue to shape even the most ancient and iconic landscapes. Ancient lava dams once blocked the river entirely. Long before human dams altered the Colorado River, nature built its own barriers. Volcanic eruptions west of the Grand Canyon sent massive lava flows spilling into the gorge, where they cooled and hardened into enormous natural dams. At times, these dams completely blocked the river, creating temporary lakes that stretched for miles upstream. Geological evidence shows that some of these lava dams were hundreds of feet high. Eventually, the river either overtopped or eroded through them, releasing catastrophic floods that reshaped the canyon floor. These events left behind deposits of basalt and gravel that can still be studied today. The geologists, the story of the lava dams highlights how dynamic and violent the canyon's history has been, shaped not only by water, but also by fire. The interplay of lava and river created landscapes that continue to bear the scars of those ancient, dramatic encounters. The river supports fish found nowhere else on Earth. Within the Colorado rivers, waters live several species of fish that are entirely unique to this system, found nowhere else in the world. Among them are the humpback chub and the razorback sucker, both adapted to the river's once turbulent, sediment-rich environment. These fish evolved in conditions very different from today's regulated flows, making them especially vulnerable to changes caused by dams and habitat loss. Conservation programs within the Grand Canyon focus on protecting these rare species, using techniques like managed flooding to restore natural habitats and carefully monitoring populations. The humpback chub, with its distinctive curved back, is particularly symbolic of this struggle, surviving in remote tributaries where conditions remain favorable. These fish remind us that the river is not only a sculptor of stone, but also a cradle of life, supporting creatures as unique and irreplaceable as the canyon itself. Floods continue to shape the canyon's form. Despite its ancient appearance, the Grand Canyon is not fixed. Seasonal floods, driven by snowmelt or heavy rains, continue to carve and reshape its features. When the Colorado River swells, it scours beaches, moves boulders, and shifts channels, altering the landscape in ways both subtle and dramatic. Evidence of past floods is written into terraces and sediment layers along the river's course. Scientists use these records to study how extreme events influence erosion, sediment transport, and ecological systems. For wildlife and plants, floods are both destructive and renewing, clearing old growth and depositing fresh nutrients. While dams have reduced the frequency of natural floods, occasional releases are designed to mimic their effects. These forces remind us that the Grand Canyon is alive, not frozen in time, its forms continuously revised by the movement of water. Even today, the river's power continues to carve new chapters into the stone. Sandbars and beaches come and go with each season. The Colorado River's constant movement reshapes sandbars and beaches along its course through the Grand Canyon. These features are built from fine sediment carried by the river and deposited in eddies, coves, and side channels. Over time, they are eroded, rebuilt, and shifted elsewhere. For rafters, these sandbars provide vital camping spots, but for scientists, they are indicators of how the river's sediment load changes with flow conditions. Before upstream dams, floods replenished beaches naturally, but today, many have diminished. Experimental floods released from Glen Canyon Dam have shown that sandbars can be rebuilt, restoring habitats for wildlife and safe spaces for recreation. This constant cycle illustrates how rivers are dynamic systems, always in flux. In the Grand Canyon, sandbars and beaches remind us that even small-scale features are part of a larger, living process, changing year by year as water and sediment interact. The river creates hidden caves along its banks. Along the Colorado River, water erosion has carved not only the canyon itself, but also countless caves, alcoves, and overhangs along its banks. These caves form where currents and floods exploit weaknesses in the rock, hollowing out sheltered spaces. Some serve as resting places for wildlife, while others preserve archaeological evidence of past human use, from fire pits to artifacts left behind centuries ago. Geologists study these caves to understand the river's historical flow patterns, while biologists examine them as unique microhabitats. For adventurers traveling by raft, discovering a hidden cave can feel like stumbling into another world, a cool, shadowed refuge tucked into the blazing walls of stone. These caves emphasize that erosion is not only about grand landscapes, but also about intricate details, each cavity a testament to the river's quiet persistence in reshaping the canyon, one pocket of stone at a bicho. Time. Geologists still debate exactly when the canyon formed. The Grand Canyon looks timeless, yet scientists continue to debate when it actually began to take shape. Some evidence suggests the modern canyon is about 6 million years old, carved when the Colorado River established its present course. Other studies propose that parts of the canyon began forming much earlier, with ancient streams cutting through sections as far back as 70 million years. Thermochronology, which measures the cooling of rocks as they near the surface, has offered conflicting timelines, suggesting some portions are far older than others. The current view is that the canyon likely formed in segments, with older valleys later joined by the Colorado River into a continuous chasm. This ongoing debate shows how even world-famous landmarks hold mysteries. The canyon is not a single creation event, but the result of complex geological processes unfolding over vast spans of time, still challenging scientists to piece together its full history. The Grand Canyon provides a natural laboratory for climate change. Because of its immense vertical range and detailed geological record, the Grand Canyon serves as a natural laboratory for studying climate change. Its rock layers preserve evidence of ancient climates, from desert sand dunes to shallow seas, offering scientists a window into how Earth's atmosphere and ecosystems shifted across hundreds of millions of years. Modern climate variation is also clearly visible within the canyon itself. In just a few miles, hikers can experience conditions similar to those found across continents, from alpine forests on the rim to scorching desert near the river. Researchers study these gradients to understand how ecosystems respond to temperature and precipitation differences. Springs, caves, and sediments also store chemical clues about past rainfall and drought cycles. By analyzing these indicators, scientists can compare ancient climate shifts with modern patterns, helping to predict how environments may respond to ongoing global change. Cosmic rays help scientists date exposed rock. One of the innovative methods used to study the Grand Canyon involves cosmic rays, high-energy particles from space that constantly strike Earth. When these rays interact with certain minerals in exposed rocks, they create rare isotopes that accumulate over time. By measuring these isotopes, scientists can estimate how long rock surfaces have been exposed to sunlight and air. This technique, called cosmogenic nuclide dating, helps determine when erosion stripped away overlying layers or when landslides and rockfalls occurred. In the Grand Canyon, cosmic ray dating has provided insights into the timing of river incision and the exposure ages of cliff faces. Unlike traditional fossil-based dating, this method is particularly useful for barren surfaces where other clues are scarce. It highlights the cutting-edge science at work in the canyon, using particles from deep space to better understand the earthly processes that shaped one of our planet's greatest landscapes. Fossils include ancient trilobites, reptiles, and ferns. The Grand Canyon's layered rocks are filled with fossils that span a wide range of ancient life forms. The oldest layers contain trilobites, marine arthropods that thrived in Earth's oceans more than 500 million years ago. Higher up, fossilized ferns and primitive plants reveal the spread of vegetation across the land. In still younger layers, tracks and bones of early reptiles show how life adapted to deserts and floodplains. These fossils are not just curiosities, they provide crucial evidence of how life evolved through different climates and ecosystems. They also help scientists match rock layers in the canyon with those found elsewhere, piecing together a global timeline of Earth's history. For visitors, the idea that the canyon walls once supported seas, swamps, and reptilian wanderers adds another layer of wonder. The canyon is not only a record of stone, but also a monument to the story of life itself. The canyon helps scientists study erosion in action. While the Grand Canyon reveals erosion on a geological scale, it also provides an active laboratory to study the process in real time. Landslides, rockfalls, flash floods, and sediment movement continue to reshape its cliffs and valleys each year. Scientists install sensors, monitor river sediment loads, and use satellite imagery to track how the canyon changes. Because the Colorado River is partially regulated by dams, researchers can also study how altering water flow affects erosion rates. The canyon's scale makes it especially valuable for understanding how rivers cut through rock, how slopes collapse, and how landscapes evolve under pressure from multiple forces. By comparing modern erosion with the long record preserved in stone, scientists can better estimate the rates of geological change. The Grand Canyon is not just a relic of the past, it is a living system, still teaching us how landscapes are carved and reshaped. Rare mineral deposits have been found in its walls. Hidden within the Grand Canyon's layers are unusual mineral deposits that intrigue scientists and collectors alike. Among them are rare crystals of azurite and malachite, which form striking blue and green patterns within limestone. Uranium deposits have also been discovered, sparking both mining interest and environmental concern over the years. Some minerals crystallized under conditions of heat and pressure deep underground, while others formed through groundwater seeping through cracks. Each deposit preserves information about the chemical and geological history of the canyon. While mining has been heavily restricted to protect the park, these minerals continue to be studied for their scientific value. They highlight that the canyon's significance is not only in its grand scale, but also in the intricate chemistry recorded within its rocks. Even the smallest veins of mineral color carry echoes of processes that shaped the earth deep beneath the surface. Rockfalls and landslides continuously alter the landscape. The Grand Canyon may look eternal, but its walls are constantly shifting. Rockfalls and landslides, triggered by weathering, rain, or freeze-thaw cycles, occur regularly along the cliffs. Some are small, sending pebbles and sand trickling down. Others are massive events, with entire cliff faces collapsing into the depths. Over centuries, these rockfalls contribute significantly to the canyon's widening and reshaping. Scientists track these events using seismometers, remote sensors, and field studies, not only to understand geological processes, but also to ensure visitor safety. Evidence of ancient landslides can be seen in piles of boulders and deformed rock layers scattered along the river corridor. These collapses remind us that erosion is not only gradual, but sometimes sudden and dramatic. The Grand Canyon, far from being a static monument, is a dynamic landscape where stone continues to move, crumble, and reform, adding new details to its already complex form. The canyon preserves layers of ancient oceans. Among the canyon's most fascinating records are the remnants of ancient oceans that once covered the region. Limestone formations filled with marine fossils show that shallow seas repeatedly advanced and retreated across the land over hundreds of millions of years. Coral reefs, shell beds, and traces of sea creatures are frozen in stone, telling the story of marine ecosystems long vanished. Each ocean left behind distinctive sediments, fine limestones from calm waters, sandstones from beach environments, and shales from muddy sea floors. By stacking these layers together, geologists can trace cycles of sea level rise and fall, as well as changes in global climate. For visitors, it is striking to realize that the desert cliffs of today were once underwater landscapes filled with thriving life. The Grand Canyon preserves not just Earth's geological structure, but also the rhythms of oceans that shape the planet's surface again and again. Some rocks bear ripple marks from beaches millions of years old. Look closely at certain layers of the Grand Canyon. and you can see delicate ripple marks etched into the stone. These patterns, frozen in time, were once created by waves and currents along ancient shorelines. Over millions of years, shifting seas deposited sand that hardened into sandstone, preserving these ripples as natural imprints. To touch them is to connect directly with the surface of a beach that existed hundreds of millions of years ago. These features provide scientists with clues about past environments, the depth of water, the direction of currents, even the energy of ancient waves. What is remarkable is how such subtle details survived through immense geological upheavals, protected within the canyon's walls. They remind us that geology is not only about towering cliffs and massive timescales, but also about the smallest preserved details, traces of quiet waves that once lapped at forgotten shores. The canyon once held inland seas teeming with life. Beyond individual shorelines, the Grand Canyon's rock layers record entire inland seas that once covered vast portions of North America. During the Paleozoic era, warm, shallow waters extended across the region, supporting ecosystems of corals, brachiopods, trilobites, and other marine organisms. These seas came and went with shifts in global sea levels, leaving behind thick deposits of limestone and fossil-rich strata. For scientists, these rocks are evidence of continental-scale changes, reflecting the rise and fall of oceans tied to plate tectonics and glacial cycles. For those who visit the canyon, it is astonishing to imagine that the desert landscape we see today was once home to tropical marine life. The canyon walls preserve the memory of these vanished worlds, where inland seas stretched to the horizon, filling what would one day become one of the driest and most dramatic landscapes on Earth. Hiking from rim to river is a journey through climate zones. Descending from the rim of the Grand Canyon to the river is not just a change in elevation. It is like traveling across continents in a single hike. Within just a few miles, the climate shifts dramatically. At the rim, cool forests of pine and fir resemble the highlands of the northern Rockies. A mile below, the scorching inner canyon resembles deserts of Mexico. Temperatures can vary by more than 30 degrees between top and bottom, and vegetation changes with each zone. Hikers experience this directly, shedding layers of clothing as they descend, while scientists use it as a living example of how altitude shapes ecosystems. The vertical drop of the canyon compresses thousands of miles of climatic diversity into one place. For those who make the journey, it is a vivid reminder of Earth's complexity, a walk through multiple environments carved into a single chasm. The Bright Angel Trail has been used for centuries. The Bright Angel Trail, one of the most popular routes into the Grand Canyon today, has a history stretching back centuries. Originally, it was a pathway used by indigenous peoples, who relied on it for access to water sources, hunting grounds, and seasonal movement. When settlers and explorers arrived, the trail was adopted and expanded, eventually becoming a key route for tourists. Mule trains began carrying visitors and supplies along it in the late 19th century, cementing its role as a main artery into the canyon. Today, the Bright Angel Trail offers a direct link from the South Rim to the Colorado River, descending through layer after layer of exposed rock. For scientists and hikers alike, it is a living timeline, where each step downward reveals new geological formations. Its enduring use shows how human pathways can align with natural features, connecting generations across the canyon's immense history. Mule rides offer a historic way down the canyon. For more than a century, mule rides have offered visitors a distinctive way to travel into the depths of the Grand Canyon. Introduced in the late 1800s, these rides quickly became a celebrated experience, combining tradition with practicality. Mules, with their sure-footed stability and endurance, are ideally suited for navigating steep trails where horses might falter. Riding one down the canyon is both a thrilling and humbling experience, as the animals carry passengers along narrow ledges with sheer drops just feet away. The practice also connects to the canyon's history, when mules were used to transport supplies and mail between rim and river. Today, mule rides remain a symbol of the canyon's cultural heritage, offering a slower, more intimate way to experience its scale. They remind us that humans have always sought creative ways to explore daunting landscapes, relying on trusted companions to help us venture safely into the depths. Adventurers sometimes attempt to cross the canyon on foot in a day. Crossing the Grand Canyon from rim to rim is an ambitious feat, one that some adventurers attempt to complete in a single day. The journey spans more than 20 miles, with a vertical descent of over a mile followed by a climb of similar magnitude. It tests endurance, preparation, and resilience against heat, dehydration, and fatigue. While park officials caution against such attempts for most visitors, trained athletes and experienced hikers pursue it as a challenge, often beginning in the pre-dawn darkness to avoid extreme temperatures. For scientists and rangers, these attempts highlight both the human drive to push limits and the canyon's unforgiving nature. Crossing it in a day compresses the canyon's immense scale into a single extraordinary effort, underscoring how vast and demanding the landscape truly is. Few places on Earth offer such a direct confrontation between human limits and natural grandeur. Extreme athletes have run the canyon rim to rim. Beyond hiking, elite endurance athletes have taken the challenge of the Grand Canyon further, running from rim to rim in record times. Known as rim to rim, or even rim to rim to rim runs, these ultramarathon efforts cover distances exceeding 40 miles when completed as a round trip. Runners endure grueling heat, steep ascents, and rapid elevation changes, often completing the journey in under a day. Such runs demand extraordinary physical conditioning, mental resilience, and precise planning for hydration and nutrition. While these feats are far beyond the reach of most visitors, they highlight the canyon's role as both a scientific wonder and an arena for human endurance. Scientists note that such runs provide useful data on human physiology in extreme conditions, while others view them as testaments to the canyon's enduring ability to inspire challenge and awe. The Grand Canyon, in this way, becomes not only a geological marvel, but also a proving ground for the human spirit. Rafting expeditions experience rapids with legendary names. Within the Grand Canyon, the Colorado River's rapids carry names that have become legendary among rafters: Lava Falls, Crystal, Hermit, and Granite, to name a few. These names reflect not only their power but also their stories, often tied to the explorers who first navigated them. Each rapid is distinct, shaped by underlying geology, fallen boulders, and the force of the river itself. Rafters spend days anticipating the approach of the largest rapids, scouting routes and preparing for their thunderous waves. Scientists study these rapids to understand how river dynamics respond to floods and landslides, while adventurers experience them as direct encounters with raw energy. The names echo in rafting lore, representing both challenge and accomplishment. For many who complete the journey, these rapids stand as unforgettable milestones, markers of courage, resilience, and respect for the untamed force of the river. Helicopter flights reveal the canyon's immensity. While standing on the rim offers breathtaking views, seeing the Grand Canyon from a helicopter provides an entirely new perspective. From above, the canyon's vast system of side valleys, mesas, and cliffs unfolds like a living map. Patterns of erosion become clear, showing how tributary canyons feed into the main gorge. The river itself appears as a thin ribbon winding through the depths, dwarfed by the cliffs above. For scientists, aerial surveys provide invaluable data on geological formations, vegetation cover, and erosion patterns. For visitors, the experience can be overwhelming. a direct confrontation with the canyon's immensity, made visible in a way impossible from the ground. Helicopter flights reveal not just the grandeur of the canyon, but also its complexity, showing how every ridge and valley contributes to the whole. The view from above confirms that the canyon is not simply vast, it is intricately, beautifully structured. Caves inside the canyon hide mysterious passages. Scattered throughout the Grand Canyon's cliffs are more than 1,000 known caves, many of them unexplored. These caves formed through a variety of processes, including erosion by groundwater, collapse of overhangs, and dissolution of limestone by acidic water. Some are small alcoves, while others extend deep into the rock, forming labyrinths of shadow. Archaeological evidence shows that ancient peoples used some caves for shelter and storage, leaving behind artifacts that endure today. Others contain fossils of animals that once roamed the canyon, from ground sloths to birds. For scientists, these caves are natural laboratories, preserving evidence of past climates, ecosystems, and geological processes. For explorers, they remain places of mystery, with many passages still uncharted. Each cave is a hidden chapter of the canyon's story, reminding us that even in such a well-studied place, there are still countless secrets waiting to be uncovered. Hidden waterfalls cascade into secret grottos. Beyond the canyon's main vistas, hidden waterfalls tumble into shaded grottos, creating oases of water and life in an otherwise arid landscape. Some, like Havasu Falls, are famous for their turquoise waters that spill into travertine pools. Others are tucked away in side canyons, accessible only to those who venture off the main paths. These waterfalls are often fed by springs, where groundwater seeps through rock layers and emerges suddenly into the open. Around them, lush vegetation thrives: willows, cottonwoods, mosses, and ferns that would never survive the canyon's dry cliffs. These grottos serve as havens for wildlife, offering cool refuge from the heat. For visitors who discover them, they feel like hidden worlds, unexpected bursts of beauty in the desert. Scientists study them to understand hydrology and biodiversity in fragile environments. They demonstrate that even in the harshest landscapes, water can create pockets of abundance and wonder. Exploring the canyon at night reveals a sky brimming with stars. At night, the Grand Canyon becomes a window into the universe. Far from city lights, its skies are among the darkest in North America, offering dazzling views of the Milky Way arching across the horizon. Constellations, planets, and meteors shine with clarity rarely seen in modern times. The canyon itself transforms under starlight, its walls fading into shadow while the sky takes center stage. For scientists, the area is ideal for studying light pollution, astronomy, and nocturnal ecosystems. For visitors, the experience can be profound, connecting the vastness of Earth's geology with the vastness of space above. Indigenous peoples have long incorporated the night sky into their traditions, linking celestial patterns with stories and guidance. Standing on the rim beneath the stars, one feels the canyon not just as a geological wonder, but as part of a larger cosmic stage, where Earth and sky meet in quiet magnificence. Some caves hold remains of ancient animals like sloths. Within the Grand Canyon's many caves, scientists have found remarkable fossils of animals that once roamed the region. Among the most surprising are the remains of giant ground sloths, massive herbivores that lived during the Ice Age. These creatures, some larger than modern bears, left bones, dung, and even claw marks in sheltered caverns. Other caves preserve fossils of extinct birds, rodents, and reptiles, capturing snapshots of ecosystems that existed thousands of years ago. Because many caves are dry and sheltered, they act like natural time capsules, preserving organic material that would have decayed elsewhere. For paleontologists, These discoveries offer invaluable insights into how climate change and human arrival shaped the region's wildlife. For visitors, the idea that giant sloths once wandered the same cliffs where condors now soar is both humbling and awe-inspiring. The canyon is not only a record of geology, but also of vanished giants. Strange wind currents sweep through certain side canyons. The Grand Canyon's complex topography produces unusual patterns of wind. Narrow side canyons act as funnels, accelerating air currents and creating powerful gusts that can surprise hikers or rafters. In some spots, wind moves with a steady roar, while in others, it swirls unpredictably, bouncing off cliffs and creating miniature whirlwinds. Scientists studying microclimates note that these wind systems affect everything from plant growth to erosion. Birds, too, use them to their advantage, riding the updrafts to soar effortlessly above the cliffs. For those inside the canyon, the winds can feel alive. Sudden rushes of air sweeping around corners or rising from the depths like invisible rivers. These air currents also transport pollen, seeds, and even insects, making them an important ecological force. The canyon's winds remind us that its atmosphere is as dynamic as its rocks and water, constantly moving, shaping, and connecting life across its vast spaces. Fossilized footprints show creatures walking sideways. Among the canyon's most intriguing fossils are tracks left by ancient reptiles more than 300 million years ago. Preserved in sandstone slabs, these footprints reveal an odd detail. The animals seem to walk sideways, moving with a gait unlike anything seen in modern species. Scientists believe these creatures were early reptiles or amphibians, navigating shifting sand dunes. Their unusual movement may have helped them stabilize on steep or unstable surfaces. These fossilized tracks are more than curiosities. They represent some of the earliest evidence of complex land-dwelling vertebrates in North America. The preservation is so precise that individual toe impressions can still be seen, frozen in stone since long before the canyon existed. For paleontologists, they offer rare clues about locomotion and adaptation in early animals. For anyone who sees them, the realization that living creatures once walked here, leaving their marks across ancient dunes, is a powerful connection to deep time. The canyon has more than 1,000 known caves. While most visitors focus on the open vistas, the Grand Canyon is also riddled with hidden spaces. Over 1,000 caves have been documented within its walls, though estimates suggest there may be many more. These caves range from shallow alcoves to deep, twisting passages, some of which extend far into the rock layers. Each cave forms differently, some carved by groundwater dissolving limestone, others by collapses along faults and joints. Many remain unexplored, offering opportunities for future discoveries in geology, archaeology, and biology. Caves provide shelter for bats, birds, and insects, and preserve fossils and artifacts from past climates and cultures. For scientists, they are natural archives, storing evidence of past rainfall, vegetation, and even atmospheric conditions. The sheer number of caves underscores the canyon's complexity. It is not only a grand open chasm, but also a labyrinth of hidden chambers within the stone. Only a fraction of the caves have been explored. Although more than 1,000 caves are known in the Grand Canyon, only a small fraction have been explored in detail. Many remain inaccessible, perched on vertical cliffs or hidden behind unstable rockfalls. Others are simply too remote, requiring days of travel by foot or river to reach. Of those surveyed, some contain archaeological treasures such as pottery, tools, and ancient shelters. Others hold fossils or mineral formations that reveal details about past climates and environments. Scientists and cavers carefully limit exploration to protect fragile ecosystems and cultural heritage, as even small disturbances can destroy irreplaceable evidence. This means the majority of the canyon's caves remain mysterious, their contents unknown. For explorers, this sense of the undiscovered is tantalizing. For researchers, it represents vast potential for future study. The canyon, despite its fame, still guards countless secrets in dark passages that may not be revealed for generations. Some rocks contain rare crystals formed in unique conditions. Beyond fossils and sediments, the Grand Canyon's rocks sometimes hide rare mineral crystals. In certain formations, groundwater carrying dissolved minerals, slowly deposited quartz, calcite, or even unusual crystals like wolfenite and vanadinite. These minerals formed under unique chemical and geological conditions, creating small but stunning treasures inside cracks and cavities. The colors range from translucent whites to fiery reds and brilliant greens, a stark contrast to the muted tones of the canyon walls. While collecting is prohibited within the national park, scientists study these crystals to understand the chemical history of the rocks and the movement of groundwater through them. Each crystal acts like a natural experiment, recording conditions of temperature, pressure, and chemistry long ago. Though tiny compared to the canyon's cliffs, these delicate structures reveal the intricate details hidden within a landscape otherwise known for its overwhelming scale. They remind us that beauty exists at every level, from the vast to the microscopic. The Echo Cliffs create sound illusions. East of the Grand Canyon rise the Echo Cliffs, a striking escarpment named for its unusual acoustic properties. In this region, sound bounces across the cliffs in ways that can confuse the ear, creating echoes that seem to come from unexpected directions. Indigenous peoples long recognized these effects, weaving them into stories and traditions. Modern visitors experience them when shouts or calls return distorted, as though multiple voices are speaking back. Scientists attribute the effect to the cliff's height, spacing, and angle, which reflect sound waves in complex patterns. These auditory illusions remind us that landscapes are not only visual but also acoustic. The Echo Cliffs demonstrate how geology can shape sound, just as it shapes rivers and ecosystems. They highlight the canyon region as a place where every sense is engaged: sight, sound, and touch, all drawn into the scale and complexity of its stone formations. Lightning strikes the canyon frequently during summer storms. The Grand Canyon is a hotspot for dramatic summer thunderstorms, especially during the monsoon season. Towering clouds gather over the plateau, releasing sudden bursts of rain, wind, and lightning. Strikes frequently hit the canyon's rims and cliffs, sometimes igniting wildfires or sparking rockfalls. Visitors on the rim often witness spectacular displays of bolts branching across the sky, illuminating the vast landscape in split-second flashes. Scientists monitor lightning patterns here to better understand storm formation in rugged terrain. For wildlife and ecosystems, these storms are both destructive and renewing. Fires clear old vegetation, while rain replenishes springs and rivers. For humans, the storms are both dangerous and awe-inspiring, a reminder of nature's raw power. The scale of the canyon amplifies the drama, with thunder echoing for miles through its walls. Experiencing lightning at the canyon is to see energy unleashed on a stage built by time and stone. Snow occasionally blankets the rims while the river remains warm. Winter brings surprising contrasts to the Grand Canyon. Snow often falls along the high rims, covering the pine forests and rocky overlooks in white. Meanwhile, far below, the Colorado River continues to flow through a much warmer climate, where daytime temperatures may remain mild and snow never lingers. This vertical contrast means that in a single day, visitors may witness winter at the rim and spring-like conditions at the river. The sight of snow draped across red cliffs is especially striking, a rare blending of desert and alpine imagery. For scientists, these conditions provide opportunities to study microclimates and how ecosystems adapt to elevation differences. For wildlife, the snowpack is vital, feeding streams and springs during the melt. This seasonal layering of climates is another reminder that the Grand Canyon compresses an astonishing range of environments into one vertical slice of the Earth. The canyon holds hidden springs that flow for millennia. Amid its arid cliffs, the Grand Canyon hides springs that have flowed steadily for thousands of years. These waters often emerge from cracks where ancient rainfall slowly percolated through rock layers before reappearing at the surface. Some springs release water that has been underground for centuries or even millennia, carrying chemical signatures of distant climates. These hidden flows create lush oases inside canyons, supporting willows, ferns, and unique wildlife. For indigenous peoples, springs have always been sacred, sources of life in an otherwise harsh landscape. Scientists study them not only for ecology but also for hydrology, as they reveal how groundwater moves through complex geological structures. Springs are fragile systems, vulnerable to drought, climate change, and groundwater extraction upstream. Yet when discovered unexpectedly, they feel miraculous. Cold, clear water bubbling from stone, proof that life endures in even the most unforgiving terrain. The Yarlung Tsangpo Gorge in Tibet is even deeper than the Grand Canyon. While the Grand Canyon is iconic, it is not the deepest canyon on Earth. That distinction belongs to the Yarlung Tsangpo Gorge in Tibet, carved by the mighty Brahmaputra River as it winds around the eastern Himalayas. At its deepest, this gorge plunges more than 3 miles from rim to river, dwarfing even the Grand Canyon's mill-deep walls. The combination of towering mountains, extreme rainfall, and powerful river currents has created a landscape of staggering scale. For scientists, the gorge is a natural laboratory of extreme geology, shaped by tectonic uplift and erosion working together. For explorers, it has long been a place of mystery, with sections so remote they were only recently mapped in detail. Comparing it with the Grand Canyon highlights the diversity of Earth's great chasms. Both reveal time and power at work, yet each tells its own unique story of how landscapes can reach the edge of imagination. Peru's Colca Canyon plunges twice as deep as the Grand Canyon. In southern Peru lies Colca Canyon, one of the deepest canyons in the world. At its deepest points, it plunges more than twice the depth of the Grand Canyon, reaching over 2 miles from rim to river. Despite its scale, Colca Canyon is not barren. It is alive with terraced farmland, small villages, and soaring Andean condors. For centuries, indigenous peoples have cultivated crops on the steep slopes, building intricate terraces that are still used today. The Colca River continues to cut deeper, while hot springs bubble along its course. Scientists study the canyon's geology to understand how rapid uplift and strong rivers combine to carve such extreme depths. For visitors, the contrast is striking. Human culture thriving within a landscape of overwhelming natural power. Colca Canyon demonstrates that great chasms are not only monuments of geology, but also homes where people and nature coexist. The Cotahuasi Canyon in Peru is among the deepest on Earth. Not far from Colca Canyon lies another Peruvian marvel, Cotahuasi Canyon. At more than 2 miles deep, it rivals Colca for the title of the deepest canyon on Earth. The Cotahuasi River carved this gorge through volcanic rock uplifted by tectonic forces, producing sheer cliffs that tower above the valley. Unlike many deep canyons, Cotahuasi remains remote and relatively untouched by large-scale tourism. Villages dot the upper slopes, where people farm terraces much as their ancestors did. The canyon's isolation has preserved unique ecosystems, including rare plants and animals adapted to its steep walls and microclimates. For scientists, Cotahuasi illustrates the interplay of volcanism, tectonics, and erosion in shaping extreme landscapes. For those who venture there, it is a place of both grandeur and solitude, a reminder that even in the modern world, there are still colossal natural wonders, little known beyond their local regions. The Fish River Canyon in Namibia stretches across the desert. In southern Africa, the Fish River Canyon cuts a dramatic scar across the Namibian desert. Measuring more than 100 miles long and up to a half-mile deep, it is the largest canyon in Africa. Unlike the Grand Canyon's forested rims, the Fish River Canyon lies in one of the driest regions on Earth. Its rocky walls and barren floor tell the story of a river that flows only seasonally, filling with water during rare floods and lying dry for much of the year. Scientists believe the canyon formed hundreds of millions of years ago, shaped by tectonic shifts and later deepened by water erosion. Today, it draws geologists, hikers, and adventurers seeking its stark beauty. The Fish River Canyon demonstrates how even the harshest deserts can bear the marks of ancient rivers, carving valleys of astonishing scale in landscapes where life clings to the margins. Mexico's Copper Canyon system is larger than the Grand Canyon. In northern Mexico lies the Copper Canyon, or Barranca del Cobre, a vast system of 6 interconnected canyons. Collectively, this network is both longer and deeper in places than the Grand Canyon, covering an area several times larger. The Copper Canyon is carved by rivers flowing from the Sierra Madre Occidental, creating a maze of cliffs, valleys, and ridges. Its name comes from the greenish hue of lichen-covered rock, which gives the walls a coppery glow in sunlight. Unlike the arid Grand Canyon, the Copper Canyon supports lush forests, waterfalls, and indigenous communities who have lived there for centuries, including the Raramuri people, renowned for their endurance-running traditions. Scientists study its geology and ecosystems as examples of canyon formation in a different climate and setting. The Copper Canyon proves that, while the Grand Canyon is unique, it is not alone. Earth holds many chasms that rival it in size and diversity. The Kali Gandaki Gorge in Nepal slices through the Himalayas. The Kali Gandaki Gorge in Nepal is often called the deepest gorge in the world, though its measurements depend on how depth is defined. What makes it extraordinary is the contrast between the river floor and the towering Himalayan peaks of Annapurna and Dhalagiri that rise more than 5 miles above. The Kali Gandaki River has carved a path through these mountains for millions of years, creating a corridor that has also served as a trade route between India and Tibet. Fossils of ancient seashells can be found high in its walls, reminders that the Himalayas themselves were once ocean floor. For scientists, the gorge illustrates how rivers and tectonic uplift interact on the grandest scale. For travelers, it offers both geological drama and cultural richness, as villages, monasteries, and trails line its slopes. The Kali Gandaki Gorge stands as a place where natural and human histories intertwine. The Indus Gorge carves through Pakistan's high mountains. In northern Pakistan, the Indus River slices a spectacular gorge through the Karakoram and Himalayan ranges. This gorge, among the deepest on Earth, lies beneath some of the highest peaks, including Nanga Parbat, which towers more than 26,000 feet above. The Indus Gorge demonstrates the immense erosive power of a river matched against rapid tectonic uplift, as the land rises while water cuts ever deeper. Scientists study it as one of the most dramatic examples of coupled river and mountain evolution. For local communities, the gorge has long served as a passage through formidable terrain, connecting cultures and trade routes. Its scale is difficult to comprehend. The contrast between riverbed and summits creates vertical relief greater than almost anywhere else on the planet. The Indus Gorge reminds us that Earth's greatest canyons are not always in deserts. but also in the hearts of the tallest mountains. The Tara River Canyon in Montenegro is Europe's deepest. Europe's deepest canyon lies in Montenegro, where the Tara River has carved a gorge more than 4,000 feet deep. Known for its clear, turquoise waters, the Tara Canyon winds through the Dermata National Park, a UNESCO World Heritage Site. Its steep cliffs are cloaked in forests of pine and beech, creating an environment rich in biodiversity. Rafting the Tara River has become a celebrated adventure, as rapids carry travelers through towering walls of stone. Scientists value the canyon as a refuge for rare species and as a model for studying karst landscapes where limestone dissolves into caves and sinkholes. For Europe, where many landscapes have been heavily shaped by humans, the Tara Canyon remains a strikingly wild place, a reminder of the continent's untamed geological past. Its depth and beauty burn it comparison with the world's great canyons, standing proudly as Europe's counterpart to the Grand Canyon. The Verdun Gorge in France is called Europe's Grand Canyon. In southern France, the Verdun Gorge is often referred to as Europe's Grand Canyon, though it is far smaller in scale. What it lacks in size, it makes up for in beauty. The Verdun River flows through limestone cliffs that rise nearly 2,000 feet, creating a striking corridor of pale stone and emerald water. The gorge is famous for its color. The river's turquoise hue, caused by glacial minerals, stands out vividly against the surrounding cliffs. Climbers, kayakers, and hikers flock to its walls, while scientists study its karst formations and unique ecosystems. Unlike the isolated vastness of the Grand Canyon, the Verdun Gorge lies within a densely populated region, blending natural wonder with cultural heritage. Its nickname may be a comparison, but its character is unique, showing how the power of water has sculpted breathtaking landscapes across the world. The Blyde River Canyon in South Africa is lush and green. Most of the world's great canyons lie in deserts, but South Africa's Blyde River Canyon is strikingly different. Covered in subtropical vegetation, it is one of the largest green canyons on Earth. The Blyde River winds through cliffs of red sandstone and quartzite, creating dramatic escarpments such as the Three Rondavels and God's Window. Waterfalls cascade into the gorge, feeding lush forests that support a wide range of wildlife, from primates to birds of prey. Scientists value the canyon as part of the Drakensberg Escarpment, a region rich in geology and biodiversity. For visitors, the contrast between towering cliffs and dense greenery feels almost surreal, a canyon that bursts with life rather than stark emptiness. The Blyde River Canyon demonstrates the diversity of canyon landscapes worldwide. Not all are barren deserts. Some are vibrant, living systems where water and vegetation thrive together in spectacular harmony. The Antelope Canyon in Arizona glows with winding light beams. Antelope Canyon, located on Navajo land in northern Arizona, is one of the most photographed slot canyons in the world. Unlike the vast openness of the Grand Canyon, Antelope is narrow and pristine, with smooth sandstone walls sculpted by flash floods over thousands of years. When sunlight filters down through narrow openings at midday, it creates shafts of glowing light that appear to dance across the walls. The stone itself is a swirl of red, orange, and purple hues, smoothed into graceful curves that look almost liquid. For geologists, Antelope Canyon is a perfect study in how water shapes stone in confined spaces, carving graceful passages with sudden bursts of force. For visitors, it feels otherworldly, a hidden cathedral of stone and light. This canyon demonstrates that grandeur is not always about size. Sometimes it is about intimacy, silence, and the play of light in spaces carved by time. Bryce Canyon is not a canyon, but a maze of stone towers. Despite its name, Bryce Canyon in Utah is not technically a canyon. Instead, it is a series of giant natural amphitheaters filled with tall stone spires called hoodoos. These formations were created through a process of frost wedging, where water seeps into cracks, freezes and expands, gradually breaking the rock apart. Over time, countless cycles of freezing and thawing sculpted the sandstone into slender towers and intricate shapes. The result is a surreal landscape, almost like a city of stone stretching to the horizon. For scientists, Bryce is a vivid demonstration of how erosion can sculpt landforms without the help of rivers. For visitors, it feels dreamlike, as though walking among ruins built by some forgotten civilization. The canyon is really a reminder that names can mislead. What matters is the spectacle of Earth's creativity, visible in thousands of delicate towers that rise against the sky. Zion Canyon towers, with sheer sandstone walls. Zion Canyon in Utah is one of the most dramatic river-carved canyons in the world. The Virgin River, though modest in size, has spent millions of years cutting through layers of Navajo sandstone, leaving behind cliffs that soar over 2,000 feet above the valley floor. Unlike the barren expanses of the Grand Canyon, Zion is lush, with cottonwood trees, hanging gardens, and waterfalls clinging to its walls. The contrast between vertical red cliffs and vibrant greenery creates a breathtaking effect. Scientists study Zion as an example of how even small rivers, given time, can carve immense landscapes. For hikers, trails like Angel's Landing or the Narrows provide unforgettable experiences, either climbing above the cliffs or wading directly through the river between towering walls. Zion Canyon is proof that grandeur comes not only from depth and scale, but also from the drama of vertical stone and the persistence of water. Kings Canyon in Australia holds ancient palm forests. In Australia's Northern Territory lies Kings Canyon, a gorge carved into layers of red sandstone that glow under the desert sun. While the canyon itself is striking, what makes it extraordinary is the presence of ancient palm trees growing in its depths. These cycads are living fossils, direct descendants of plants that thrived more than 100 million years ago. They survive here in sheltered grottos where water collects and temperatures remain cooler than the surrounding desert. For scientists, Kings Canyon is a unique refuge that preserves species from prehistoric times. For Indigenous Australians, it is a place of deep cultural significance, with stories and traditions rooted in the land. Visitors who walk along the rim trails or descend into the Garden of Eden, where pools and palms create an oasis, experience a canyon that is not only geologically beautiful, but also biologically and spiritually alive. Waimea Canyon in Hawaii is called the Grand Canyon of the Pacific. On the island of Kauai in Hawaii lies Waimea Canyon, often nicknamed the Grand Canyon of the Pacific. While smaller in scale than its Arizona counterpart, Waimea is equally spectacular, stretching 10 miles long and more than 3,000 feet deep. What sets it apart is its vivid coloration. Layers of volcanic rock, weathered by tropical rainfall, create cliffs of deep reds, greens, and purples. Waterfalls spill from its walls, feeding lush vegetation that clings to terraces and valleys. Waimea Canyon formed not from tectonic uplift, but from the collapse of a massive shield volcano, later deepened by erosion. For scientists, it reveals the interplay of volcanic activity and tropical weathering. For visitors, it offers a vision of canyon beauty in a tropical setting, where vibrant colors and cascading streams contrast with the dry landscapes more typical of great canyons elsewhere in the world. The Gorge du Verdon is famous for its emerald waters. In southeastern France, the Gorge du Verdon winds for 15 miles between cliffs of white limestone. earning a reputation as one of Europe's most beautiful river valleys. Its walls rise nearly 2,000 feet, but the most striking feature is the Verdon River itself, whose waters shimmer in shades of turquoise and emerald. This unusual color comes from glacial minerals suspended in the water, scattering sunlight in brilliant hues. The gorge was carved over millions of years as the river cut through the limestone plateau, leaving behind caves, cliffs, and towering walls. Scientists value it as a classic example of karst erosion, where water not only cups valleys, but also dissolves rock to form underground passages. For travelers, the gorge combines geological drama with cultural richness, surrounded by villages and fields. The Gorge du Verdon is proof that canyons are not just vast scars on the land, but places of great beauty shaped by chemistry, light, and water. The back canyon of the Gunnison has some of the steepest cliffs. In western Colorado lies the Black Canyon of the Gunnison, a gorge known for its dramatic steepness. Unlike the wide expanses of the Grand Canyon, the Black Canyon is narrow and vertical, with walls that plunge more than 2,000 feet in places. At its narrowest, the canyon floor is only 40 feet across, making its cliffs appear even more imposing. The Gunnison River carved this chasm with extraordinary speed, slicing through hard metamorphic rock at one of the fastest rates of erosion ever measured in North America. The canyon gets its name from its dark appearance, as sunlight reaches the bottom for only a few minutes each day. Scientists study it to understand how rivers cut through some of the toughest rock on Earth. For visitors, it is both beautiful and intimidating, a canyon that feels less like an open landscape and more like a cleft in the planet itself. The Samaria Gorge in Crete is a haven for rare wildlife. On the Greek island of Crete lies the Samaria Gorge, a dramatic canyon stretching more than 10 miles through the White Mountains. Its walls rise over 2,000 feet, creating a corridor of cliffs and forests. Unlike many arid canyons, Samaria is green and filled with life. It is home to the cri-cri, a rare species of wild goat found only on Crete, as well as many endemic plants and birds. Scientists value the gorge as a biodiversity hotspot, where isolation has allowed unique species to thrive. The gorge also carries cultural history, as it served as a refuge during wars and invasions throughout the centuries. Today, it is a protected national park and UNESCO Biosphere Reserve. Hiking through Samaria offers not just geological beauty, but also encounters with wildlife and history, making it one of the most remarkable canyons in Europe. The Kapiti Valley in Australia is wider than the Grand Canyon. While the Grand Canyon is famed for its depth, Australia's Kapiti Valley surpasses it in width. This massive sandstone valley, located in New South Wales, stretches nearly 30 miles across, making it the widest canyon in the world. Unlike the sheer cliffs of Arizona, the Kapiti Valley is more open, with vast escarpments and mesas rising above forests and grasslands. It is also one of the most important bird habitats in Australia, home to the endangered regent honeyeater and many other species. Scientists study the valley for its ecosystems and its geological history, shaped by erosion of the sandstone plateau. For visitors, the scale can be surprising. Standing on the rim, the openness feels endless, more like a lost world than a canyon. The Kapiti Valley shows that canyon grandeur is not only about depth, but also about breadth, with landscapes that stretch beyond the horizon. The 9-Mile Canyon in Utah holds thousands of petroglyphs. 9-Mile Canyon in Utah is sometimes called the world's longest art gallery. Stretching more than 40 miles, it contains thousands of petroglyphs and pictographs created by indigenous peoples over centuries. The canyon walls are covered with images of bison, hunters, spirals, and abstract designs, etched or painted into stone. Some date back nearly 2,000 years, offering glimpses into the lives and beliefs of the Fremont culture and other groups. While the canyon is not as deep or dramatic as the Grand Canyon, its cultural richness is extraordinary. Archaeologists study the art to understand communication, spirituality, and daily life in ancient societies. For modern visitors, walking through 9 Mile Canyon is like entering a museum carved by human hands into natural rock. It demonstrates that canyons are not only geological wonders, but also cultural landscapes where people have left their mark for millennia. Some canyons form from glacial ice, not just rivers. While most canyons are carved by rivers, glaciers can also create immense valleys. As massive rivers of ice move slowly downhill, they grind against bedrock, plucking and scraping away stone. Over thousands of years, this process carves broad U-shaped valleys, distinct from the narrow V-shaped canyons formed by rivers. Famous examples include Yosemite Valley in California and the fjords of Norway, where glacial erosion created some of the most dramatic landscapes on Earth. Scientists study these glacial canyons to understand the power of ice in shaping continents. For visitors, the difference is striking. Steep walls, flat valley floors, and often lakes or rivers filling the spaces left behind. These icy canyons show that erosion is not limited to liquid water. Frozen water can sculpt land on a colossal scale, leaving behind valleys that rival any river-cut gorge in grandeur. Submarine canyons carve the ocean floor. Canyons are not limited to the land. Beneath the ocean, enormous submarine canyons slice into continental shelves and slopes. These underwater valleys can be as large as those on land, though hidden from view beneath thousands of feet of water. They are carved by turbidity currents, powerful underwater landslides of sediment, and by rivers that once flowed when sea levels were lower. Submarine canyons act as highways for nutrients, funneling organic matter from coastal areas into the deep sea. This makes them hotspots of biodiversity, supporting ecosystems from plankton to whales. Scientists study them with sonar and submersibles, revealing landscapes every bit as dramatic as the Grand Canyon, though few will ever see them directly. Submarine canyons remind us that Earth's greatest chasms are not only on the surface, but also in the hidden realms of the oceans, shaping marine life on a planetary scale. The Monterey Canyon beneath the sea rivals the Grand Canyon in scale. Just off the coast of California lies Monterey Canyon, one of the largest submarine canyons in the world. It begins near the shore of Monterey Bay and plunges more than 2 miles deep into the Pacific Ocean floor. Its size rivals that of the Grand Canyon, but it is entirely underwater. Scientists explore Monterey Canyon using remotely operated vehicles, revealing cliffs, valleys, and sediments shaped by undersea landslides and currents. The canyon acts as a pathway carrying nutrients into the deep sea, making it an oasis for marine life. Squid, fish, octopuses, and deep-sea corals thrive in its depths, along with species still unknown to science. Because of its accessibility near shore, Monterey Canyon has become one of the most studied submarine canyons, helping researchers understand not only geology, but also deep-sea ecosystems. It shows that even beneath the waves, Earth holds landscapes as grand as any on land. Canyons can form on other planets like Mars. Canyons are not unique to Earth. Space missions have revealed that Mars, in particular, is carved by immense canyons. Ancient water, lava flows, and tectonic activity combine to create chasms far larger than anything on our planet. These Martian canyons provide evidence that the red planet once had flowing rivers and perhaps even seas. Scientists study them to reconstruct Mars's climate history and to search for signs of habitability. The fact that canyons exist beyond Earth demonstrates that erosion and tectonics are universal geological processes. They occur wherever planets and moons have solid crusts, gravity, and energy to drive change. For us, it is thrilling to imagine standing on another world and looking across a canyon as vast as any on Earth. Canyons are not only terrestrial wonders but cosmic ones, reminders that planetary landscapes evolve with striking similarities across the solar system. Valles Marineris on Mars is 10 times longer than the Grand Canyon. The most spectacular canyon in the solar system is Valles Marineris, a colossal rift on Mars. Stretching more than 2,500 miles, it is about 10 times longer than the Grand Canyon and up to 4 times deeper. Its sheer scale is almost beyond comprehension, large enough to stretch across the entire United States. Scientists believe it formed from tectonic forces that cracked the Martian crust, later widened by landslides, lava flows, and perhaps ancient rivers. For planetary scientists, Valles Marineris is a treasure trove, preserving clues about Mars's geological past and the processes that shaped its surface. For the imagination, it is staggering to envision standing on its rim, looking across a chasm so vast it disappears into the horizon. Valles Marineris reminds us that while the Grand Canyon is Earth's masterpiece, the universe itself contains landscapes even more immense. Titan, Saturn's moon, may hold canyons filled with liquid methane. Saturn's moon Titan is one of the most unusual worlds in the solar system. Covered in thick orange haze, it hides rivers, lakes, and even canyons carved not by water but by liquid methane and ethane. Radar images from the Cassini spacecraft revealed deep, branching valleys feeding into Titan's hydrocarbon seas. These canyons are hundreds of feet deep and remain filled with liquid, an alien counterpart to the river canyons of Earth. For scientists, Titan offers a glimpse of how familiar processes can play out in completely different chemistry. It demonstrates that canyons are not limited to water erosion, but can form wherever a liquid flows across solid ground under gravity. Titan's canyons expand our understanding of what is possible, showing that even on frigid moons far from the sun, landscapes echo the familiar forms of valleys, rivers, and cliffs. Canyons can shape local wind and weather systems. Canyons are not only geological features, but also atmospheric ones. Their immense walls and depths create unique wind patterns, temperature gradients, and microclimates. The Grand Canyon, for example, experiences daily cycles where cool air sinks at night, forming river-level inversions, while warm air rises to the rim during the day. Winds accelerate through narrow passages, while storms may build along rims before descending into depths. These effects influence ecosystems, plant growth, and even human experiences of comfort and risk. Similar phenomena occur in canyons worldwide, from desert gorges to tropical valleys. Scientists study them to understand how topography shapes weather on both local and regional scales. For visitors, these conditions can be felt directly: sudden gusts, sharp temperature shifts, and storms that seem to appear from nowhere. Canyons demonstrate that landscapes and atmosphere are inseparable, each shaping the other in a continuous, dynamic relationship. Echoes in canyons help scientists study sound physics. Canyons are natural laboratories for acoustics. Their walls reflect sound in unusual ways, creating echoes, reverberations, and distortions. Scientists use these settings to study how sound waves travel through complex environments. In the Grand Canyon, for example, a shout may bounce back delayed and multiplied, while in narrow slot canyons like Antelope, echoes can be sharp and rapid. These natural theaters help researchers understand not only geology, but also applications in sonar, architecture, and communication. Indigenous peoples often incorporated canyon acoustics into rituals, recognizing their unusual auditory qualities. For visitors, the effect can be startling and beautiful, voices amplified, instruments resonating in unexpected harmonies. Sound in a canyon is a reminder that landscapes are experienced not only with the eyes, but with the ears. In their echoes, we hear the hidden dialogue between stone and air, a natural concert shaped by walls of rock. Canyons inspire artists, poets, and dreamers across cultures. Throughout history, canyons have stirred the imagination of artists, poets, and travelers. Their vastness, mystery, and beauty make them natural subjects for creative expression. Indigenous cultures have long woven canyons into their stories, songs, and traditions, viewing them as sacred spaces filled with meaning. In modern times, painters have captured the play of light across canyon walls. Writers have described the overwhelming sense of scale, and photographers have sought to frame their colors and forms. Scientists, too, are often moved by the landscapes they study, inspired to ask deeper questions about time and change. Canyons stand as reminders of both power and patience, symbols of endurance carved by forces invisible on human timescales. For dreamers, they represent journeys into the earth, into history, and into imagination itself. In every culture, canyons remind us that science and art often meet in wonder. Exploring canyons reminds us how small we are in a vast world. To step into a canyon is to confront scale in its rawest form. Towering walls rise overhead, carved over millions of years by forces far beyond human control. Rivers flow at the bottom, indifferent to the footsteps on their banks. In such places, our own lives and timelines feel fleeting, measured against stone and water but endure across epochs. Yet this sense of smallness is not diminishing, it is expansive, inviting awe and humility. Scientists study canyons for the knowledge they reveal, but explorers and travelers also seek them for perspective, for the reminder that Earth is vast and ancient, and we are but a small part of its story. Whether in Arizona, Peru, Tibet, or even on distant Mars, canyons are monuments to time, change, and persistence. They remind us of where we stand in the universe, tiny, but capable of wonder. As our journey comes to a close, take a moment to let the vastness of these canyons settle in your mind. From the depths of the Grand Canyon to the hidden valleys of distant worlds, we have traveled through landscapes carved by time, water, ice, and even methane rivers on faraway moons. Each canyon tells its own story of patience, of change, of the quiet power that shapes worlds over millions of years. To explore them is to be reminded of the scale of nature and of our own place within it. Small, yes, but never insignificant. We are witnesses, able to learn, to wonder, and to carry these stories with us. If you enjoyed this calm exploration, you're welcome to like and subscribe or share a thought in the comments below. It helps others find their way here too, one sleepy soul at a time. For now, let the day fall behind you. Close your eyes, breathe deeply, and drift into rest as the rivers of time continue their patient work, shaping the world in silence. Good night.